Hello students, it's Dr. Marks and our topic for today is the production possibility frontier and slope. Now we may have hit this in class, but sometimes students struggle with this, so it's a good idea to watch this relatively short lecture and make sure that you totally understand the topics. Quick review. In class we worked with a production possibility set that looked like this one to the right. We simplified the world to two goods, and so remember the PPS here shows all of the possible bundles of goods that can be produced. We're not distinguishing at this point between efficient and inefficient. This is just every bundle of mobile phones and cameras that can be produced. Now remember the purple border is the production possibility frontier. So we have to make a distinction between the production possibility set, which is the whole graph, and the production possibilities frontier. Remember the frontier, where we see points A, B, and C, and we could put a bunch of other points, shows us all of the efficient bundles of goods. So production possibility frontier is the efficient set, just the border, whereas the production possibility set is all bundles. So efficiency in this context is where output is maximized. So if you look at points A, B, and C, we can't produce any more than that. We can switch between A and B, right? We can go from A to B. We gain some cameras, we give up some mobile phones, but we can't get to any point where we have both more phones and cameras. The shape of this PPF, as I've drawn it right here, we're going to call bowed outward. This will just help us have some common language, so I have a way of indicating what I'm talking about. So this looks like kind of a quarter of a pie, and we're going to call this bowed outward. Now again, remember, what we see here is that if we move from point A to point B, it involves a trade-off, right? We should be able to see that as we go from A to B, we get more cameras, but we give up phones, right? So going from A to B, we gain more cameras, we give up phones. So in this case, we have to give up one to get more of the other. Well, we just showed in the previous slide that we have a trade-off, right? As we go from A to B, we gained cameras, we gave up phones. We have this idea of a trade-off. There's a trade-off in going from A to B. So we have an opportunity cost. Now that opportunity cost tells us what we give up to get more cameras. So we've got some simple numbers here that we can work with. You have to know how to calculate opportunity cost. Opportunity cost is always foregone over gained. Foregone over gained, but it depends on which points you're going to. So we're going from A to B. Do you agree that we are gaining cameras? So that goes on the bottom, cameras gained. And on the top we have the phones that we give up. Remember, we're freeing up resources by producing fewer phones and diverting those resources into cameras. You have to get this equation right. I can't emphasize this enough. If it is upside down when you take a quiz or a test, guys, you're going to get absolutely everything wrong in an entire section of the test on trade. So foregone over, gained. I point out that alphabetical order is a good way to remember it. Foregone, F before G. Again, if you get it upside down, everything's going to be wrong when we get to the trade units. So alphabetical order. All right, so now we can make some calculations with our equation for opportunity cost. So here's our opportunity cost. It's going to be phones foregone over cameras gained. So take a look at the numbers. I've circled them. We're going from A to B. So when we go from A to B, do you agree we gain 10 cameras, right? We went from 10 to 20. We gained 10 cameras, but we give up only one phone, right? We had 8, now we have 7. So we gain 10 cameras, we give up one phone. So when we plug this into the opportunity cost equation, remember foregone is on the top, we give up one phone to gain 10 cameras. Now, we always want to reduce this, so 1 is on the bottom. And you're going to see why when we get into the trade unit. It's going to be a lot easier for us to make comparisons. So if I have 1 over 10, that reduces to 0.1 over 1, right? So 1/10 of a phone per one camera. So 1/10 of a phone is given up to produce one more camera. That's the opportunity cost. So if I ask you to calculate opportunity cost, I'm asking you to plug in the numbers, reduce it like that, and then come up with a reduced form of that same equation. Let's now go from B to C. Same thing that we did before. Do you agree we gained 10 cameras, right? We went from 20 to 30, but we give up 4 phones because we went from 7 to 3. So the opportunity cost here is 4 phones are given up in order to gain 10 cameras. Again, we've got to reduce the equation. On a test, that's not what my answers are going to look like. So if it's multiple choice, you're not going to find the right answer until you reduce the fraction. So 0.4 phones divided by 1 camera. So what that tells us is 0.4 or 4/10 of a phone are given up to produce one more camera. Let's compare. Going from point A to B had an opportunity cost of 1/10, but going from B to C has an opportunity cost of 4/10. Do we see what's happening here? The opportunity cost is changing along the PPF. In this case, the opportunity cost got bigger as we produced more cameras. So as we have more and more cameras produced, we have to give up more and more phones. This is what we call the law of increasing cost. So the law of increasing cost says that as we produce more and more cameras, we're going to have to give up more and more mobile phones for each camera. And we see that. This is where we get that bowed out shape that we're talking about. So when I see the bowed out shape, I should be able to immediately, without even seeing any numbers, know, oh, the law of increasing cost is at work. That means opportunity cost is increasing as I move to the right. So between A and B, we said the slope is 1/10. Between B and C, the slope is 4/10. So slope is getting bigger, right? Hopefully you're making the connections. When we calculated opportunity costs, all we were doing was rise over run. It's a measure of slope, okay? So slope is getting bigger as we produce more cameras because opportunity cost is getting bigger. Well, opportunity cost and slope are the same thing. Let's see it another way, and this will help you out. So if I'm talking about slope and that doesn't really compute with you, this will make it a little easier. So let's look at these tangents that I've put in the green lines. Do you agree that that's measuring slope, right? Slope is simply a measure of steepness. So I can measure the slope with that tangent. Look at the first green line and the second green line. Do you agree that the tangents are getting steeper and steeper? Well, that tangent is a measure of slope. So the slope is getting bigger and bigger as we move to the right, which tells us opportunity costs are getting larger and larger. Again, make sure you haven't missed the key point. Opportunity cost is simply a measure of slope, right? Change in one over the change in the other. Rise over run is slope. So one more time, opportunity cost is nothing more than a measure of slope. So here with this bowed out PPF, we see slope getting bigger. Since slope and opportunity cost are the same thing, that means opportunity cost is getting bigger. Now, what if we have this type of PPF instead? What if we have this PPF instead? So let's go from points A to B. And do you agree our opportunity cost is 20 units of Y are foregone? How did I figure that out? We had 120, now we're down to 100. And 40 units of X are gained, right? We have on the X-axis, I had 40X, now we have 80X. So when I plug in, remember it's always what's foregone over what's gained. So 20Y are foregone, 40X are gained, foregone over gained. But I've got to reduce this, so let's reduce it to 1Y over 2X. But I remember I've got to reduce it even further because I need 1 on the bottom. So 20y over 40x reduces to 1y over 2x, which reduces to 0.5y over 1x. So you've got to be able to do these basic math things, okay? So hopefully that was really easy for you and you totally follow that. If not, come see me for some additional help. The opportunity cost here tells us that is if we give up 1/2 of a unit of y, we can get 1 more x, right? So if I want 1 more x, we have to give up 1/2 of a unit of y. So that's our opportunity cost here in this example. Again, remember you've got to get in the habit of reducing to 1 on the bottom, or else this will get very confusing. So we want to know the opportunity cost of 1 more x. Even though we're really getting 40 more x, I want to reduce it so that I know for each 1x. Now let's go from B to C. Again, do you agree that the opportunity cost is that 20y are given up, 20y foregone, because we go from 100 to 80, and 40x are gained. We go from 80 to 120. So again, I can reduce that to 1/2, right? 1y over 2x, and I can reduce that to 0.5y over 1x. So the opportunity cost of getting 1 more unit of x is still 1/2 unit of y. It's the same, in other words, right? So what we want to make sure we understand is that the opportunity cost of going from A to B was the same as going from B to C, right? Well, in this case, then, opportunity cost is constant for this PPF. But that's not surprising. Again, let's make the connections. We've already said opportunity cost is a measure of slope. All we're doing when we calculate foregone over gain is rise over run, right? So opportunity cost is a measure of slope, and the slope doesn't change along a straight line, right? The steepness is constant. It never changes on that straight line. So if the slope is constant, then opportunity cost must also be constant. So we want to think about how this example compares to the bowed out example in the bowed out PPF. It wasn't a straight line, so the slope changed, but it doesn't change here in this example. Here's a numerical example, and I put it in chart form from this linear PPF, and that will help you see it a little bit better. So all I've done is taken the numbers from the graph and I've put them into a chart. So I've picked points and then put it in a form that's easier to understand. That's all I've done here. Now again, you want to always get in the habit of reducing your fractions so we have 1 on the bottom, but I haven't done that here so that you can kind of follow my work. So be very clear. Let's take a look at this table. If we go from 0 to 40x, we have to give up 20y. And if we go from 40 to 80x, we still give up 20y. And if we go from 80 to 100x, we give up 20y. In each case, we gain 40x, we give up 20y. That's where that constant opportunity cost is coming. That's slope being constant along a straight line. Now, here's a PPS that's not that realistic. So if you look at the production possibility set on the right, I'm not suggesting that we would see this in the real world because we usually see increasing cost, and that's why we have that law of increasing costs. And that's why we normally would see bowed out PPFs. But I might give you one like this simply to test your understanding. We're going to call this bowed in or bowed inward. So we have bowed out, we have linear, we have bowed inward. So let's think about what we can conclude about this production possibility frontier based on what we've learned about slope and opportunity cost. As we produce more and more of good A, what must be happening to the opportunity cost? Can you figure out the pattern? Well, is the opportunity cost going up? Is the opportunity cost constant, or is the opportunity cost actually falling? In this case, as we produce more and more of good A, the opportunity cost is actually falling. Well, how do I know that the opportunity cost is falling? By looking at slope as we move towards A. So let's take a look. I've got the hot pink line, and then I've got the purple line. Do you see what's happening on the right with the tangents? The tangents are becoming less steep. I'm also giving you a numerical example below. And you see in this numerical example, we give up less and less of good B for every additional unit of A. So we understand the graph on the right? We see the tangents, they're becoming less and less steep. But now let's look at the chart. If we go from 0 to 1 units of A, we give up 3 of good B. Let's say I want one more A. We're going to go from 1 to 2. Well, now we give up 2 of good B. I need a third unit of A, so we go from 2 to 3. But here I only give up 1 unit of good B. Do you see what's happening here? The opportunity costs are actually decreasing. As I said, in the real world, we're not going to see this, so I'm only going to ask you this kind of a question for testing your understanding. So make sure you're clear at this point. We've got bowed outward PPFs, we've got linear PPFs, and now we have bowed inward PPFs. And you need to understand what that tells us about slope and what that tells us about the pattern of opportunity cost. Here's one more thing to note. In all of these examples, we increased what was on the horizontal axis, right? We always move to the right. Now, can we move to the left? Yes, we could go in the opposite direction. So look at this example here. What if I want to decrease boats? Well, now I'm moving to the left. If I decrease boats, I'm going to increase trucks. Does that make it any different? The answer is no. We work it exactly the same way. So we want to produce more trucks, less boats, right? Everybody with me? You see that we're moving to the left instead of to the right. As I just said, you're going to do exactly the same thing we did when we were moving to the right. It doesn't matter which direction you're moving on the PPF. So let's go from A to B. Remember, in our other examples, going from A to B was a movement to the right, but now we're moving to the left. Everyone agree, as we move from A to B, we gained 3 trucks. We had 4, now we have 7, so we've gained 3 trucks. But to do that, we had to free up resources, and we gave up 2 boats. So take a look and make sure you believe that. We've gained 3 trucks, so we're moving up the vertical axis. We've given up 2 boats, so we're moving to the left on the horizontal axis. So plug in the numbers, guys. Remember, what's foregone over what's gained. It's still the same equation. In this case, what's foregone is the boats. So I put 2 boats, foregone, divided by what's gained, 3 trucks. So 2 boats foregone divided by 3 trucks gained. So if I reduce this to be 1 on the bottom, what that tells me is 2/3 of a boat are foregone for each 1 truck gained. If you're not sure how you do that math, look at the previous line. So let's go back for a second. Look at that right there. If you don't know how to reduce that, what do I need to do to get 1 on the bottom? I need to divide the numerator by 3 and the denominator by 3. When I divide the numerator by 3, it gives me 2/3 boats. When I divide the denominator by 3, it gives me 1 truck. So that's how I got to the next step, that 2/3 of a boat are foregone for each 1 truck. And again, you're going to be responsible for this basic manipulation of fractions, okay? So make sure you're understanding how I'm getting these numbers. Now let's go from B to C. Do the same exact thing. We're gaining 2 trucks, right? We went from 7 to 9. we give up 3 boats. So our opportunity cost is going to be 3 boats foregone, right? Because we went from 7 to 4, and we've gained 2 trucks. So take a look and make sure you agree with those numbers. So we've given up 3 boats. 3 boats are foregone in order to gain 2 trucks. Now we need to reduce it. Remember how I reduce it. Maybe you've already got the right answer, but if you're having trouble with this math, let's make sure. So look at this equation here. What do we need to do to get a 1 on the bottom? To get a 1 on the bottom, we have to divide by 2, right? So we have to divide the numerator by 2 and the denominator by 2. So 3 divided by 2 gives me 3/2 in the numerator. 2 divided by 2 on the bottom gives me 1. So that gives me 3 divided by 2 on the top, which I can reduce to 1/2, divided by 1. So what this tells me now is 1.5 boats are foregone for each 1 truck gained. Do we see increasing opportunity costs as indicated by the bowed out PPF? Yeah, we do, right? When we went from A to B, we gave up 2/3 of a boat to get a truck. When we went from B to C, we gave up 1/2 of a boat to get a truck, right? When we go from A to B, our opportunity costs are smaller. When we go from B to C, our opportunity costs are bigger. So opportunity costs are getting bigger. There's nothing confusing about this. It's exactly the same set of calculations and the same way of thinking about it. So as we see, the law of increasing cost does hold even if we're moving to the left. So it doesn't matter if we're moving to the right and getting more boats or if we're moving to the left and getting less boats. The calculation is the same. You're still going to have increasing costs. You just have to plug in things differently to your equation. All right, so bottom line, it doesn't matter which direction we're moving. Let's quickly recap. We're going to see 3 shapes for PPFs in homework, quizzes, and tests. And these are bowed out, linear, and bowed in. That's what I'm going to call them. Remember that opportunity cost is simply a measure of slope, right? Foregone over gain. We're simply taking change in y over change in x, or if we're going the other direction, change in x over change in y. It's still a measure of slope. So guys, when you know one, you know the other, right? When you know one, you know the other. If you know the pattern of opportunity cost, you know the pattern of the slope. If you know the slope, you know the pattern of opportunity cost. If you know the shape, then you know both the opportunity cost pattern and the slope. For example, linear. If I give you a linear PPF drawing, you should be able to say, hey, a linear PPF has a constant slope. And since slope is a measure of opportunity cost, it has a constant opportunity cost. It does not change. If you're given a table and you find that opportunity cost is constant, then you know it's linear, right? So if I give you numbers, you can now find the shape. See what I'm saying? If I know it's a linear PPF, I know opportunity cost is constant. If I give you a table and the pattern of opportunity cost is constant, then you know it's linear. So you can go back and forth between the two. If I give you a table and you find the pattern of opportunity cost is increasing, well, then you must know it's a bowed out PPF. And of course, if you're given a table and you find the pattern of opportunity cost is decreasing, then you know it's bowed inward. So you've got to be able to connect all of these dots. The graph, the slope, the pattern of opportunity cost, they're all related. So you should be able to go back and forth between these ideas. As I said, when you know the shape, you know the pattern of opportunity cost. When you know the pattern of opportunity cost, you know the shape. Be sure you also review the content on law of increasing cost. Remember I said that there would be a handout posted to Canvas. You need to read it so that you can understand exactly why we see the law of increasing cost. And again, law of increasing cost tells us opportunity costs in the real world increase, and that means that in the real world we see PPFs that are bowed out. Thank you so much for listening, guys. Have a fantastic day. Email me with any questions.